All right, today's Tennessee State Standard is to know and apply the properties of integer exponents to generate equivalent numeric expressions. For example, 3 squared times 3 to the negative 5th power equals 3 to the negative 3rd power, which equals 1 over 3 to the 3rd power, or 1 divided by 3 to the 3rd power, which equals 1/27. Your lesson objective. I am learning to simplify real number expressions by multiplying and dividing monomials. You need to pause the video and write that on your notes. All right, so here we have some units of length, and I know that you've either already covered them in science class or you will be covering them in science class. So a millimeter, it takes 10 of them to make a centimeter. So 1 times 10 millimeters makes a centimeter. So a millimeter is 10 to the 0 power. A centimeter is 10 to the 1st power. So I want you to think about this and be prepared to discuss it tomorrow. I want you to examine the factors in the middle column and the exponents in the last column and see if you can find a pattern that would help us continue to fill out that table even further than 1 million. All right, your vocabulary: a monomial is a number, a variable, or a product of a number and one or more variables. We will also later refer to it as a term when we get into algebra. All right, so knowing what we know about exponents, 3 squared is the same thing as 3 times 3. And 3 to the 4th is the same thing as 3 times 3 times 3 times 3. Now, when we multiply those together, we actually have 3 to the 1, 2, 3, 4, 5, 6th power. So we actually have 6 factors, 2 factors times 4 factors. Note they both have the same base of 3. Your rule for product of powers: to multiply powers with the same base, you add their exponents. So 2 to the 4th times 2 to the 3rd is equal to 2 to the 4 plus 3, which equals 2 to the 7th. In algebraic terms, a to the m times a to the n equals a to the m plus n. So all you do is keep the base and add the exponents. Now, if you don't see an exponent, it is a 1. 5 squared times 5 to the 1st power would be 5 to the 2 plus 1, which equals 5 to the 3rd. And you have to pay attention. Are they asking you to evaluate it or express it as a power? This is expressed as a power. If we expressed it or evaluated it, 5 to the 3rd would be 125. All right, keep the base, add the exponents, which gives us c to the 8th. All right, when you have coefficients, -3 is a coefficient and 4 is a coefficient, you have to multiply those. So -3 times -4 is -12, but then you keep the base x and add your exponents, 2 plus 5. So that would be -12x to the 7th. Here are some more examples. So we have 9 to the 3 plus 2, which equals 9 to the 5th. Notice it says express using exponents, so that's as far as we need to go. I'm going to come down here to do this. A to the 3 plus 2 equals a to the 5th. Remember, when we have coefficients, we're going to multiply those. So -2 times -8 is positive 16. M, what's our exponent if we don't see one? It is a 1, so m1 plus 5, and that would equal 16m to the 6th. Now if we divide monomials, we have 5 to the 7th, which means we have 5 times 5 times 5 times 5 times 5 times 5 times 5. We multiply it 5 times. If we divide by 5 to the 4th, we multiply 5 4 times. Now, if we put these as 5 times 5 times 5 times, and then we match up our denominator and numerator. You can see that 5 divided by 5 is equal to 1. That's why we have the canceling out marks with these 5s. So that's also 1. So we actually have 3 factors left. 5 times 5 times 5. Your rule for quotient of powers, to divide powers with the same base, you subtract their exponents. So 3 to the 7th divided by 3 to the 4th is 3 to the 7 minus 4 power, which equals 3 to the 3rd power. Algebraically, a to the m divided by a to the n is equal to a to the m minus n. All right, so using exponents, remember, when we divide, we keep the base and we subtract. So 4 to the 8 minus 2 is 4 to the 6. It says express using exponents, so that's as far as I go. Keep the base of n, subtract the exponents. 9 minus 4, always top minus bottom, equals 9 to the 5th. Keep the base of 5, top 7 minus bottom 4 equals 5 to the 3rd, still expressing using exponents. Keep the base of x, top 10 minus bottom 3 equals x to the 7th. Now, the same with multiplication. When we have coefficients, we're going to go ahead and divide those. So 12 divided by 2 is 6. Keep the base of w, top 5 minus, we don't have an exponent, so what is it? It is 1, which would give us 6w to the 4th, w, sorry. All right, real world example. Hawaii's total shoreline is about 2 to the 10th miles long. New Hampshire's shoreline is about 2 to the 7th miles long. About how many times longer is Hawaii's shoreline than New Hampshire's? Well, this is a division problem. Hawaii's 2 to the 10th divided by 2 to the 7th equals 2 to the 10 minus 7, which equals 2 to the 3rd. And, they don't say express it or leave it as an expression with exponents. So it's better to do too much than not enough. 2 to the 3rd is equal to 8. All right, so we're going to group our 2's together, our 3's together, our 5's together. So now we have 2 to the 5 minus 2 times 3 to the 5 minus 4 times 5 to the 2 minus 1. I'm going to drop down here. So that would be 2 to the 3rd times 3 to the 1st. And you don't have to put that. I just put it so you can see it. You could just leave it as 3 because 3 to the 1st power is 3. And then 5 to the 1st. And no note as to whether to leave it with exponents, so we're going to go ahead and multiply it. 2 to the 3rd is 8. 3 to the 1st is 3. 5 to the 1st is 5. Now I'm going to use a little commutative property here because I know that 8 times 5 is 40, so that I can say 40 times 3 is 120. All right, group them with similar bases. So we would have 3 to the 4 minus 2 times 5 to the 2 minus 1 times 7 to 5 minus 3, which would give us 3 squared times 5 to the 1st, we don't have to put it, times 7 squared. 9 times 5 times 49. I'm going to have to do a little bit of multiplication here. So 49, I'm just going to do times 45 because 9 times 5 is 45. Just get this in one problem. 5 times 9 is 45. 5 times 4 is 20 plus 4 is 24. Bring down a 0. 4 times 9 is 36. Carry your 3. 4 times 4 is 16. 19. 5 and 0 is 5. 4 and 6 is 10. Carry your 1. 9 and 1 is 10 plus 2 is 12. Carry your 1. So my answer would be 2,205. Okay, now we have -2 to the 5 minus 2 times 3 to the 4 minus 1 times 5 to the 7 minus 4. No, go away. Which gives us -2 to the 3rd times 3 to the 3rd times 5 to the 3rd. -2 to the 3rd is -8 times 27 times 125. And I'm going to let you multiply that and we'll talk about it tomorrow. That's the end of our lesson.